Hi everybody, welcome to the GoLab edition 2024. I'm super excited to introduce you all to my session entitled Swiss Knife for Go Debugging with VSCode. So let's get started. For those of you that don't know me yet, I'm Pesenti, 29 years old. I live in Bergamo, in the north of Italy, and I'm working as a software engineer for CrowdStrike, and I'm also recently part of the Docker Captain program. I'm a mentor, speaker, technical writer, course author, and so on. Among my hobbies, there are anime, tattoos, and football. So, my humble goals for this today's session. Let's see what I would like to achieve by the end of this session. Basically, I would like to stop hearing those things which I don't agree with around the debugging. So the first one is that debugging is useless and time-consuming, and you should only need to deal with it only when you have something to actually debug, and do not need to bother with it ahead of time. The second thing that always made me laugh is, you know what, I'm switching to GoLab since VS Code doesn't allow me to properly debug my code. And to me, the IDE choice should be a matter of preferences, and it's not like VS Code doesn't allow you to do that properly. And the last one is the most dreaded one, which is console.log, which translates to funct.println in the Go ecosystem, and is the practice that consists of a logging statement with values and functions that are invoked up to now onto the shell. And this practice tends to get the code more bloated and harder to read. So I think that it's better to stick to design tools such as an IDE. So to accomplish this mission, I'm gonna rely on 4 players. VS Code, which is my integrated IDE of choice, Go, of course, the DAP, which is the debug adapter protocol, and Delve, which is our debugger. So why we should care about debugging? First of all, because it allows us to get a better knowledge of the code base that we are working with. It can help us in following execution paths that our code might take and further dig into them. Of course, the main reason should be to detect bugs and hopefully to fix them. And this allows you to slow down the code in a specific part to better dive into it. And finally, it allows you to inspect variable values and how they change while the code is being executed, and also it allows you to set some values to that variable. Let's take a step back. What we can debug, and the spoiler is everything. At a glance, we can debug unit tests, integration tests, CLI-based applications, processes that have been started locally, and processes that have been started remotely, or in general, any piece of code in our mind. So let's talk about the DAP, or Debug Adapter Protocol. I'm gonna talk about it by starting from this diagram, which is taken from the documentation, and let's focus on the uppermost part of it. So on the left, we have the VS Code, which has a generic debugger UI interface, which provides us with the basic debugging capabilities. Mounted inside VS Code, we have the Go extension that allows us to write a Go program in VS Code. Instead, on the right part of it, we have Delve, which is the debugger that is based on this session. And we have also the debugger, which is a typical Go program. And what is the debug adapter protocol? So the debug adapter protocol is nothing but a set of rules and standards that ruled out the communication between the Go extension and the debugger. But since it's not feasible that debuggers will adapt to this standard, or at least in the short time, a new component has been needed. And this is a debug adapter, where originally it was a legacy debug adapter, which is a tiny component written with TypeScript that allows the interaction between those 2 components. There is also a newer implementation of the debug adapter, which is called DLV-DAP, which aims to get a tighter communication between the Go extensions and the debugger by getting rid of that tiny component. So the rule of thumb should be to stick to the newer implementation and we can see how to opt from the legacy one to the DLV-DAP, and fall back only on the legacy for not yet supported feature, and ideally you should open up also a ticket where you stump against one of them in order to make the service better, let's say. So let's summarize the diagram. So debug adapter protocol is a set of rules and standard, and the debug adapter component is needed because the debugger won't adapt to the DAP in a short period of time. So that's why we need this intermediate component that allows us to support new debuggers in new IDE. Let's talk about Delve, which is our debugger. So Delve is the Go debugger. So it's been written with Go, and it's been designed with a Go program as the target. So unlike other debuggers that have been around for a while, such as GDB, it has some benefits, for example. So it's Go routine aware, for example, and is also part of the Go tooling system. So it can be installed, updated together with the other Go tools that we have. And it has also an NDCLI interface, so it can be used even if you don't have any IDE installed on a specific machine. So, and that could be a feasible scenario, for example, on a production machine. So the key features of Delve are, it allows you to customize the debug behavior. It allows you to run and debug your programs at touch by enforcing what is known as headless config. It allows you to attach to, it's like a two-step process. You start the process that you would like to debug, and then you attach a debugger instance to it. It allows you to handle the debug session by using the regular commands, such as pause, continue, restart, step over, step into, step out, and so on. It allows you to set breakpoints, which can be normal, conditional, functional, or log point, and it allows you to inspect variable values or functions that we have in our stack trace. VSCode. So why is worth using, in my opinion? Because it's free and open source, and is also completely customizable. So we can customize almost everything, appearances, extensions, shortcuts, and so on. I love the idea that VSCode sits in the middle between a full-fledged IDE and the regular text editor. So as long as you keep adding extensions, you can bring it closer to a full-fledged IDE, or you can use it also in a lightweight text editor version, let's say. It fits very well for Go programs, and I also really love the fact that I can write Go code together with C code, and I don't have to switch from one window to another. VSCode provides us with some built-in variables, such as workspace folder, which is the path of the folder opened in VSCode, file, which is the current open file, CWD, which is the current working directory for the debugger. Let's talk about the settings.json file. So the settings.json file is the home of all of our VSCode settings, and those settings are the same one that are presented in the graphical user interface, and it allows us to customize everything in order to boost our productivity and consistency. A typical example of a config that we can find in the settings.json file is the delve config, where we can set the debug adapter to be either DLV-DAP or legacy. And this setting, if we set a config here, it's applicable to all of our projects unless we override in another file, which is the launch.json file. So the launch.json file allows us to specify a specific configuration to run and debug our code, and it provides us with different arguments based on the piece of code that we are working with, and it's basically, it prepares the input for the Delve debugger, which at the end of the day we are still debugging with Delve. So it's accessible through the run view menu, and then you are provided with a link which is called create a launch.json file. If you hit on it, you will be provided with an empty launch.json file, which has a button called Add Configuration. If you click on it, you will be provided with a snippet that allows you to start selecting a configuration and work on it. So for example, in Go, we have 3 configurations that we can work on and use as a boilerplate. So time for warming up and see some code. The first program that we will see is a program that is accepting user input provided by the terminal. So here we have to set in our launch.json file a field called console, which is set to integrated terminal. And in this way, we can link the integrated terminal of VSCode with our program. So every time that our program needs an input provided by the terminal, it will pause and wait for the input to be entered, and then it will resume the execution. And this can get around the thing to hard code values just for the sake of debugging. Another thing are global package variables, which are variables that are scoped to a specific package. In this case, those variables are hidden by default, but we can make them visible by setting show global variables to true, and then we can go from a situation like this one, where we cannot see person greeted, to a situation like this one, where person greeted, which is a global package variable scoped to the package main, is visible among the other variables, variables value. Lastly is how to use the debug console REPL. REPL stands for read, eval, print loop, and is the opportunity to invoke directly function in our debug console, which is available while we are in the middle of a debugging session. And here we can prepend the function identifier plus its arguments with the keyword call, and then we can evaluate the function invocation directly there. Now it's time to see other example. So we will start with a sample unit test. So this test has been written with the table-driven test approach. And for example, we would like to run and debug only the last test case of our suite. For example, our suite will have more than one test case, and we care only about the last one. So how we can do that? We have two options. First of all, a conditional breakpoints. So you set a breakpoint on the UUT that has been invoked. UUT is the unit under test. So you set a breakpoint there, and then you turn the regular breakpoint into a conditional breakpoint. And you assign a condition that will pause and hit the breakpoint only when it evaluates to true. Or we can stick to our launch.json file, where we have the mode to set test, because we are testing, and then we are provided with the args field, where we can specify our values that will be passed. So for example, here we care about debugging the test calculate amount function, but we can also be more specific and provide a full path to that specific test within the suite. Integration test suite follows a similar approach. So here we have our inventory test suite, and we are adding 3 test cases. And again, we care about debugging the last one, which is the EpiPath one. And this is an integration test. So our launch.json file will look a little bit different. We have the build flex in this case, because otherwise we cannot debug and run integration test. And then we are also provided with a testify specific parameter, which is called M, and we can specify the specific test within the suite. So now things get a little bit more spicy. So let's suppose that we would like to debug a process that has been started locally on your machine. So it's like a 2-step process, and here we have to enforce what is known as headless config. But we need to do something before. Let's see what. The first thing is to enable the process trace. Process trace or ptrace involves 2 processes, the tracer and the tracee. So it's the ability for the tracer to start a process, the tracee, and look at its internals and also be able to set some values on it. We have 3, this is done by using the YAMA security module, and we can assign 4 values, from 0, which is the least restrictive one, to 3, which is the most restrictive one. And in this case, I need to set it to 0 in order to be able to go ahead with this thing. And then another thing that we should care about is how you compile your binary. In this way, you have to specify the GC flags to that value, because in this way you enable the debug symbols, and also you disabling inline optimization that might interfere with the debugging. then you run your binary locally, and the launch.json file looks like something like this. So the request is not launched, as we saw before, but is attached because the debug has been already started. The mode is local, and then we have to specify a process ID. So to specify the process ID, we have three options. I'm going to focus only on the third one, which is set it to 0 in the launch.json. And when you start the debugger instance, the command palette will ask you for the local PID to attach to. And then you can start by typing the name of the binary, which is MS Building in this case, and then you are provided with the right PID to listen to. And then you can debug, like in this kind of situation, where you have a CURL command, you can trigger the processes that have been started locally, and then you are good to go. Another thing very, very important to me is the compound configuration. So let's suppose that we have an outline like the one presented on the left. So we have multiple microservices that have to be started together and debugged at once. And our desired configuration is the one that you can see in the below image, which is one profile for each microservice and one profile that will bring all of them up at once and provide you with the ability to debug all of them. So the launch.json file that we need is something close to this one. So we have to specify every specific configuration for each of the microservices that we care about. And then we have the compounds configuration, which we can assign a name to. And we have a configuration which is nothing but a collection of other configurations that should be started together. And then we have also the stop all field, which is a Boolean value that tells whether to stop all of these services at once or not. And then when you are in the middle of a debug session, in the debug control pane, you are provided with a little drop-down that allows you to select between the microservice that you care about, and in the debug console, you will have the relevant log for that microservice. The final challenge will be to debug a process that has been started in a remote Docker container. So a process, if it's started in a Docker container, is like a remote process, even if the container is running on your machine. So in this way, we need to tweak a little bit the Docker file by exposing two ports, one for our web server and one for our debugger, which is the 2345. Then we have to install on the target container the delve command, because we need delve to be up and running there. Then the build command will be similar to the one we saw before. And then our entry point command will be to start delve, to listen to localhost port 2345, and headless config set to true, because it's a kind of two-step process. Then the log, we would like the log to be set to true, and also we accept multiple clients. So we can attach with multiple clients to it, and if we detach one client, the service will still be up. The API version of the debugger instance will be 2, and then we exec our binary on the remote Docker container. So those are the two commands that we need, first of all, to build our Docker image, and second, to start a container based on that image. So the launch.json file here is a little bit different. First of all, we have to set the mode, which is remote. Then we are asked to set the port, which is required, and we set it to 2345. The host is optional. If we are in localhost, we can omit it. And then the most important thing is the substitute path. So the substitute path is the translation between your host computer and the path of folders that you have on the target container. So this is important to set, because otherwise when you try to set a breakpoint in your VSCode, the breakpoint will be grayed out because it cannot find the target file system, target file in that specific file system. So it's very important to set. And then the last thing to do is to invoke our remote container and invoke it by issuing, for example, a CURL command, and then you are good to go and you can debug it. So on the left, there is a QR code for a GitHub repo I used to craft this presentation. And on the right, there are my socials. So feel free to add me and see you around. Thank you, everybody, for the attention.